So let's start doing this question. This was, I think, yesterday's lead code question, or yesterday's or day before yesterday's daily lead code challenge question. And I, I skipped that because it was a weekend and I could not do it. But let's solve this together now. Design, add, and search reverse data structure. Okay. So what does the question say? Design or data structure. Design or data structure that supports design, add, and search words. Design, add, and search words. Okay. Design a data structure that supports adding new words and finding if a and finding if a string matches any previously added string. Implement the word dictionary class. Word dictionary initializes the object. Void add word adds word to the data structure. It can be matched later. Or bool search word returns true if there is any string in the data structure that matches word, or false otherwise. Word may contain dots where dots can be matched with any letter. Okay, so it means that whenever I'm calling this new word dictionary, whenever I'm initializing the object word dictionary, this is called, so I need to initialize, this is like a constructor, I need to initialize. And whenever I'm adding add word bad, right, so this will add word to the data structure. um, so suppose if I'm adding B, A, and D, then I'm just adding it, right? And another one is D, A, D. So another one is D, A, D, D, A, D, and another one is M, A, D, M. I'm just adding to this data structure, M, A, D. And whenever I'm searching, then if the word is in this data structure, then I should return true, right? If there is any string in the data structure that matches the word. So word may also contain dots, and dots can be matched with any letter. It means that, so if I'm searching for PAD, then is there PAD here? No, so it will return false. Is there BAD here? BAD is here, right? So it will return true. And is there dot AD here? Dot AD. So if I'm searching for dot AD, then dot means like dot can match any character, right? So it can be it can be PAD or DAD or anything. So let's see. So dot can match any character. So this, and there is AD, right? So there is BAD and DAD as well. So this will be true. And is there B dot dot here? There is B here and there is dot dot. Okay. I am thinking like, what if a word is like, suppose there is BADY, then would B dot dot return true or false? Would, as I said, BAD return true or false? I think it would return false, right? Because there is a there is a prefix, because BAD is just a prefix of this word BADY. It is not a word, it is not a complete word in itself. So yeah, so any word that we are searching for, it needs to be a complete word, not a prefix. Okay, and let's see the constraints. Word dot length is from 1 to 25, and okay, so it means that word will not be empty. It means that, okay, it means that the word, the string will be of at least length of 1, and word in it contains, okay, so it only consists of lowercase English letters. There are no any uppercase English letters or any other ASCII characters or anything else. And word in sorts consists of dot or English letters, okay, but sorts can contain dot, and there will be at least 3 dots in word for sorts queries. Okay, so there can be b dot dot dot, but there cannot be b dot 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 because there are 4 dots there. And at most 10 to the power 4 calls will be made. Okay, got it. So I was just thinking if we should use the prefix, or what is that called, prefix tree data structure or something, right? Um, I'm just thinking if this data structure is suitable for this question or not, because I saw, it's like it is there is insertion, there is search. So while sorting also, it would be very easy if we have a prefix tree, right? Because suppose, I'll just revert this to original. So this is our original tree, right? After adding these words, so whenever I'm searching for any word, so if I just if I just use a prefix tree data structure, and if I insert everything, so this is my prefix tree data structure, then uh, then it will be easier to search, isn't it? So suppose there are other word also. Okay, so suppose we are adding another word also, suppose b-a-b-y, baby, and it would be, if it is a prefix tree data structure, then it would be b-a-b and b-a-b-y, baby, right? So this will be my prefix tree data structure. So if I'm searching for like, I thought of prefix tree data structure because search is really easier, because we only need to match the first characters, and if the first character doesn't match, then we can just return false immediately. Like when we are searching for pad, then I can just see if the first character is there or not, right? So is there first character here in the first label? No, there is no p in the first label of this tree, so it means that there is no any, you know there is no any word for that, so I can just return for true immediately. So yeah, that would save me lots of time. I do not need to go. I do not need to look, because we could also do this with array, but if we did this with array, then it would take off n time, right? Because we would need to, it would take a lot of time, because we would not need to look at all the words and check all the words or not, check all the words. So check if pad is there or not. Okay, p is not here, then we need to check another word baby also. So if we are not using prefix tree, then what would happen is, we would first of all check bad. Okay, is because these are the words, right? bad, and dad and nad, right? So if we are not using prefix data structure, then we would use a data structure like an array or something, and we need to look at all the words one by one. So first of all we would look if p is present, if this word matches. So okay, p is not present, so it means this is not true. We'd also need to look at this word again. So p, okay, no, we need to look at this word again. Okay, no, so it means that we need to look at all the words present in the present in this data structure. But when you are using prefix to data structure, then we not need to look at all the words, but we just need to um, we just need to because if in a prefix tree data structure, we are adding the words with the same prefix, right? So bad and baby, they have the same prefix bab, right? So it will go through the same thing, pad baby. So we only need to look for the prefix. We do not need to look for all the words now. Okay, so that was my thought. That's why I thought that, okay, prefix tree data structure would be easier to search for the word. And other than that, let's see how to do this. So searching is relatively easier, right? Because I have already done a insertion, because I think it was 3 or 4 days ago, there was a question, LeetCode Daily Challenge question for implementing prefix tree, which I already implemented, searching and inserting. So searching and inserting in prefix tree is quite, it is not that it is quite simple, because I've already done it. So let me walk through that again. but this is a new case, so there was no thought while implementing prefix tree, so I need to think of this, how to do this. So before thinking of how to manage this thought, I will just go through the inserting and searching words in the prefix tree. So while inserting, um, what I need to do is, first of all, there is a root, and then I need to, and then I need to, so for if and then I need to see. So suppose the root is empty, right? Suppose there is nothing in the beginning, there is nothing, and I need to insert word bad. Then I will first check if this has any children with a character b or not. If it has no any children, then I would just insert. Okay, now I will just update current. So the current node will be b now. So it does b has any children with character a? No, right? So I would insert a, and I can see this. So the current will be d now, and I'm done, right? So next time when I'm inserting baby, I will just start from the root only. So this will be my current node in the beginning, and then I'll see if the root, if the current elements children, does anyone, any children contains b or not, because I'm trying to insert baby here, right? So first of all, I'm trying to insert b. So I just, for what I'm trying to insert at the current, so I'm trying to insert b, and current children b is already here, right? So I will update current to this node, and I will see now a. So does b has any children a? Yes, right? So I'll update current to a, and now I'll see, does b has any children? So till now I have gone till ba, right? So there is ba in the tree already. So now after a, is there a b? So I would see if current node has a b as its children. So current node only has t, right? It doesn't have b. So it means that I need to insert a new node called b, and now b will be current node, and b doesn't have any children, so I need to insert y, and this will be my current. So like that, I just keep on updating current, and then insert in a prefix tree. And so for storing the children of a root of a node, I would use a hash map, because actually I could also make use of an array, because it only contains lower English case letters. So I can just store in array, but I will only talk about hash map right now. Okay. So in this solution, I will make use of hash map. So for hash map, what I should do is, first of all, there is root node, and root node will have character value as a key, and then the corresponding node as a value, as a value. So if suppose if this root had m as a children, then it would be m dot node m, right? So this is a node m, this is a node b, and this is a root node. So whenever I'm checking if the root node has children b or not, whenever I'm inserting for baby, and I'm checking if root has children b or not, then what I do is I just look at this root node's children and see if it has a key called b or not. So checking if the hash map has a value called b or not, it only takes a constant time, right? So the time complexity would be a constant time for retrieving, for looking at the children, for checking if there is a value, or if there is a if there is a character or not. So, and actually simple insert is like that. I'm not talking about dot condition. Okay, I'm just talking about a simple adding. So adding, I talked about adding, and searching is also similar to insert. So first of all, suppose if I'm searching for baby, then I will first of all start from the root. Root will be the current in the beginning, and then I'd see if the children has b or not, right? And then okay, it has b, so current will be updated to b, and then I'd see if b has a as a children or not, because a is the next level. Okay, B had children A and A had children B or not. Okay, B had children Y or not. Okay, so when I reach till the end, and if there is a all the characters in tree, then I return true. So let's code that first. I mean, if I code, then it will be easier to the viewers also. So I just want to code that, and I think that I also need to tweak the code as well. So I'll just write a code in first. So in the beginning, what happens is here, first of all, I need to, so I will just write a code for insertion and deletion, for insertion and sorting, simple insertion and sorting first. Okay, so I'm thinking, should I write a code first, or should I think about the solution? Okay, I'll just write a code first, if in case any viewers, if they do not have done, if they don't have seen implementing prefix tree before, they will it will, if I code, then it will help them understand how to implement a prefix tree, because prefix tree is a kind of a new data structure, if someone has not used it before. So I'll just code it. I'll just first of all, in first step, I'll code the implementing, I'll code the prefix tree, insert, simple insert and search, without thinking about dot case. Okay, without thinking about the if the word contains dot or not. And in the next time, I will consider words with dot as well. So I'll do number one first. So let first of all, we need a node, right? Because we always start from a node and go to another node. So let so first of all, it will be this dot root will be equal to node. So we need to create a new dictionary for node as well. So variable node will be equal to tree node will be equal to this dot, I can say prefix tree node. Prefix tree node will be equal to, so root will have a structure like this, right? It will have a children, so this dot root is equal to children. Children will be a hash map, right? So this is finished, this is it. And I think that I also need to I also need this dot is word or not. So I need to know if so suppose if I'm searching for BAB, then BAB is here, but I need to know if BAB is a complete word is or BAB is just a prefix of this word, right? So I'll also insert this word in the beginning, which is set to false in the beginning. So I think you'll be more clear of about the use of this that each word later when you see in coding. So this that true will be equal to new prefix tree node, right? So whenever someone calls initializes the word dictionary function, then first of all the prefix tree node will be initialized. And add word, what add word does is this dot root is equal to new. What add word does is, first of all, we are trying to add word, right? So first of all, let current node will be equal to this dot root, right? Because we always start from the root node, and then so because we are trying to insert all the characters, right? So character of word, we are trying to insert everything. So if current node has that children, right? If we see that current node has children with a key ch, then what should you do? If it does not have a children, then we should insert new, right? Then we should say that current it is equal to new node, right? New prefix tree node, new prefix tree node. And yeah, because if it doesn't have a children, then we are trying to So if so, suppose if you are insert to trying to insert BADY, then since D does not have any children, right? So we are trying to insert BADY. So now this node will be a children of D. So D, the D node's children will be equal to a hash map, and hash map's key will be Y and new node. So this will be a new node and key will be Y. So that so that we can access Y's node from these children like this. So whenever we say that current node the children ch, now it will return this node, right? Because the value is the node next node. So now we need to update current node, right? So we are updating the current node, and at last we need to set this dot word is equal to true. Yeah, I think this third word should be here. This third is word in word dictionary. Or where should it be? Oh, it should be at each node, right? So yeah, it should be here only. So for every other node, for every B also it is false, A also it is false, D also it is false. Y, for Y it should be true, right? Because the word ends it at Y. So we can just say word in this that word in. So word in is true, right? At last. Or where should we put this that is in word in? Because the word dictionary, it is a root, and this dot word in is equal to false for every current node dot word in. I'm just trying to check if current node dot word in is equal to true, right? Because this is a node at last. So all the nodes word in is false by default, and right, by default whenever we are calling prefix tree node, then by default the word int will be false for all the node. But for the last node we should set that current node that word int is equal to true. Okay, I think this would work. So at the in for searching also it is similar. So even if there is no word, then we should return false immediately. At last we should return true. So yeah, I mean that if so this code it is similar, right? So first of all, suppose we are searching for BAD, then okay, it is so first of all the root node, and we see if B is at the children of root node or not. It will be at the children, right? So B will be the current node now, and now next is A. So so we'll see if A is children of B or not here. If it is not, then we'll return false. Otherwise we'll update current node to A, and we'll see if D is children of A or not. If it is not, then we'll return false. If there are just BAC, suppose BAY, then in the tree A children will only have Y, right? So it will just return false immediately. Otherwise if we go till the end of this character in the word and still it doesn't return false, then at last we return true. So this is how we search and insert in the prefix tree. So we are done with this step 1. Now we will do the step 2. So let's see if it runs or not. It should run some cases, right? It would run for some cases, I mean for these 2 cases, though if it doesn't run for these 2 cases. So let's see. Cannot read property of undefined. Current node the children. Oh, this is children. Oh. So in the case one, so see, these two is these two options, they are correct, but only these two options are incorrect. So it means that our implementing prefix tree, it is working. Now let's think about these dot cases. So when we are looking at dot, so in this scenario, so let's see. Um, so this is our we are searching for dot ad, right? So if this is our tree, then if we get any word, then I think we should skip it, right? So when we are checking, uh, so this is a current node first, right? So this is a root node, and this is our current node. So when we are checking if current has children something or not, then we don't even need to check, if current has children something or not. So it means that in this case, we have to look at all the paths. We also need to look at this path, this path, this path, all the paths, because sometimes um, right, because dot can be anything, so we need to look at all the possible paths. So this is also our possible children, this is also possible children, this is also our possible children. So whenever we are looking at dot, then it should be current will be equal to, then, because in a normal scenario, we're doing is current node is equal to current node the children sees, right? But current node will be multiple now. So if this is a current, now current node will be multiple. So this will also be our current node. We should also look at it is like a DFS. We need to do it like a DFS. So we will also look at we'll also check at this first. We'll also check at this. We'll also check at this path as well, all the path, because dot can be anything. Yeah, I think that would work. So let's see if double dot works or not. So if there is b dot dot, then what should we do? So suppose if there is b here, and then there is b here and dot dot. So if there is a dot, then like we said, we will always look for other numbers. This will be my current node. Both will be current node, and if one of them is true, then I should return true immediately, right? So b, there is a dot here and there is a dot dot, so both will be my current, right? Because I will go at so many paths. So if one of the path returns true, then I should just return true immediately. And I was thinking, if there is b dot dot, this b, there is a b and dot. So I was thinking if I can make use of number, how many dots are there. So if there are 3 dots, then suppose if there are 3 dots, then I can just, maybe I'm just thinking, maybe I can just say that, okay, there are dot of 3 length, so I can just traverse through three times. So 1 2 3. Yeah, that is similar actually, because that is same thing. I don't even need to uh, calculate the length of all the dot, and then go dot 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 like that. Okay, so is there any use cases that I am not thought about? So till now I am thinking that whenever there is a dot, then I will just, whenever I encounter dot, dot do kind of DFS, right? DFS, and go through all the paths, check through all the paths. If any path is valid, then return true immediately, right? So suppose if I'm calling for b dot ad, then dot, first of all I'm looking at this children, then AAT. Okay, we already found dot AD, so I'll just return true true true. But suppose if this was dot AC, then B, I will look at first BAD, then but what if, like, if it had dot AC dot again, there will be so many multiple branches, right? Multiple branches, because it might be like I'm going at this path A C, and okay, and there is a dot again, then it means that if there is dot again, then I have to go through all the numbers, right? If there is a dot, then I need to go through all the numbers, right? So if there is dot, then, and CD, suppose E. Okay, now it means that I need to backtrack and then go to another branch now, ED, suppose, and then suppose there is a dot again here, then however many times I encounter a dot, I need to look at all the branches. So suppose this is D, F, G. Yeah, so I encountered dot here, now I look at all the branches. AC, I encountered dot here, now I look at all the branches, whatever the branches are. Okay, now this branch is done, now I come back and then look at all the, okay, so isn't it like a data DFS kind of thing? I'll just backtrack. Okay, is there any like use cases or something? BAT. What if I encounter multiple times sequentially, then what will happen? So suppose here, and there is a dot here and then dot again here, right? Then I need to, it means that I need to go to the other branches again. Okay, let's code then. Let's try to code this. I think this might work. Okay, before coding, I just want to make sure again I want to make sure that this algorithm works or not. So if we are looking with dot, then I'm going to all the values, right? So AC, if I encounter dot, then I'm going through all the paths, all the strings. I don't find here, then I'll, okay. There's b dot c, then it will be okay. Let's see. So the current node will change now. Current node now it means that first of all, if it starts with dot, then what will, suppose it first of all, let's say that it starts with E only. Also consider starting with dot. I will think about it later. First of all, let's think about a simple case where it starts with A and then, right, A and then another children is, I'll call this, first of all this will be current node and this will be current node, and yeah, while inserting, actually dot is also the same, right? Oh, I don't need to insert dot. Yeah, I only need to search. So while searching, so suppose we are searching for A, suppose we are searching for something, and okay, A is matching. After A character there is A matching, C is matching, right? So C will be my current now, current node will be C. And whenever I encounter a dot element now, suppose if if ch is equal to dot, and they were also saying that there will not be three dots, more than three dots, right? Okay, so if, does it mean something? They are saying that there will not be more than three dots. I don't think so. There will at least three dots in word. uh, so I'm thinking, so does this mean something, like I can I optimize with this information? Because right now I'm saying that whenever I'm using dot, then I'll go through all the branches. Even if there are just three dots also, then I need to do the same. So ch is equal to dot, and if ch is equal to dot, then it means that current node is, right? So if it is AAC dot, if it is dot, then current node will be all the children of the present node. How to code this? Because if I find that next character is dot, right? So if I find that next character is dot here, then I need to look for all the children, right? So suppose I mean there is dot here, so I need to look at all the children of T. There is dot here, so I need to look at all the children. Okay. Okay, so dot here means that after C there is a dot in the source word, so I need to look at, so this is these all are C's children. Okay, I think that was fine. It was more clear when I did this, that I can see that these all are C children, so there is a dot, and that's why I'm looking at all the C children. So if ch is equal to dot, then what should I do? Then there will be so many children. I need to look for every children. So because before if c1 if c after c, if there are no dot, there is a dot in search word. So after c, if there is no dot, I can write the similar here also, so it means that after d. So if I write so in the beginning I was just doing it going linearly, right? So a children is a children is c children is d children is e. So I'm just to see if A, C, D, E is present in this prefix tree or not. I'll just look at A children is A, C, D, E. It is just a kind of linear. I'm not branching anywhere. But now A, C dot. Now I need to branch. Now I need to check if A, C, D, E, A, C, D, E here, and for everything. So so what I need to do is C's C's children is, there is a dot in source word, so six children dot. So I need to check a. Until now I am checking a children is a, and a c. Now six children is dot. So now I need to branch, right? So I need to look for d, e, and everything, and then while this is returning, if there is false, then I need to look for another branch as well. So children, I need to now for character and node of calling the children, right? So this is a key and this is a value. So if this is a key and this is a value, then what was this new character? So this is a d, right? So first of all it will pass d and then d. If cs is w dot, then now this will be a character. So I check this here, right? So if current node the children has this character or not. If it has this character, then current the children new h will be equal to new prefix. Oh, I'm doing everything here in a add function, but it should be in a, this is fine, it should be here. I'll just put this upward so that again it is easy for me to see this. Okay, so if ch if ch is equal to dot, then what we should do is for new node current the children node, if current node the children so should I use a recursion here because we are doing DFS? Why am I doing like I mean I can also use for loop iteratively, use something, but I think that recursion would be better here. Because I need to pass, right? If I'll just pass check if word present and character will be new character. So this will be a new character, and what I can do is function check if word present for any character. I can for any character, and I should also have a current node, right? But since this function is within this, so current node will always be available within this function also, since this is a nested function. So I can just do this right here. So if current node's children has a character, then I return false. So this function would then I return false, otherwise yeah. So A, A, C, D, E, F, this is a tree. A, A, C, D, E, F, this is a current node, and here I can see that check if word present, so this will return false immediately right here. Check if character present, something like that. So if this character is present, then okay, this will return false. Now after D we should also look at E, after E we should also look at F, and if this returns false, then I need to look at other character here. So I think that because I think that we also need to pass the words, the word that we are passing, its index, so that I can check after that index only. So let's say let I is equal to 0, I is less than word dot length I plus plus, and constant ch will be equal to word I, right? And I also need to pass the index here, so that this is my index, so that I can do this here for I is equal to, so this is index, start index, and I will check if word is present or not from here, right? So it will be like yeah, so it will be like for let I is equal to 0, I is less than word dot length I plus plus, and if current node the children character, then return false, or I have to current node is equal to current node dot null, and at last I'll return true. So yeah, means that in the beginning it is like I'm passing current node and I will be equal to 0 in the beginning, and character will be equal to um so what this function does is, instead of passing new node, instead of passing this, I'll just pass current node here. Or what should I do? Should I pass current node or should I pass new character here? So here C is a current node, and the all this, you know, all the F, all these are its children, right? D, F, G, these are children of this current node. So what I'm trying to do is and the source word is AAC dot E dot something. So since I encountered a dot here at this index, I would like to look at all the possible values. So I'd like to check this DEF also, and I'd like to check if it matches this direction also. So first of all, the current node be equal to D. So actually what I can do is, if ch is equal to dot, then what I should do is I should first of all check if current node has this new, I mean if this is this has this or not. If current node ch, if this value is there or not, or yeah, I mean if C, because I'm just trying to say if, so C, after C there is dot, right? And what we're trying to check is, I'm trying to pass for all D, F, G, D. Okay, I think what I can just pass D, F, G, D actually, you know. I don't need to pass for, I just can pass this all the new nodes at this. This is not a new character but a new node or next node. So the next node will be equal to, this is a next node, right? This is the children. Yeah, so I can just pass a children node, and then I don't need to pass this new character, because I just need to pass D and the index of I. So index I will pass I plus 1 because I need to check from E now, right? Because D, F, G, they are all a dot. So I need to check from E. So if E equals to this E or not. So yeah, I think that's great. So this is a new node. This is a current node. So yeah, I'll just start from the start index. Yeah, I not so I just wrote all everything here, right? So I mean I is equal to start index and I is less than word dot length I plus plus ch is equal to, so everything is here. I do not need this here. I can just call this function and then pass 0 as a start index and then pass current node or this start root here. And then I'll just return this value if it is present or not. Yeah, so first of all this start root in the current node is the start root and 0 is the start index. So so first of all ch is equal to word I and right, ch is equal to word I, and if ch is equal to dot then I would do this. Otherwise if ch is not equal to dot then otherwise I do this, right? If ch is not equal to dot. So yeah, so it means that if ch is not equal to that, right? So first of all there is a and a will be, so I'm just dry running through this code. So in the beginning there is a and the word here is a and this is my prefix tree. Okay, so I can see in the prefix tree that the root node has children a. So I look so and cs is, since cs is not equal to dot, so I'll look go here and then see if current node has children character or not. If current node has children ch or not. Otherwise if it doesn't have children then it will return false. Otherwise current node will be updated. So now the next current node will be ai and new ch will be equal to a. So now I will check if, since this is not dot, so now okay I will go until here, right? So now I see that okay ch is equal to dot. Now what to do? Since ch is equal to dot, now I need to look at all the children here. I need to look at D, F, G, and D. So first of all, I will go through this path. Now, first of all, I will I will say that current node is D, and next time I will say that current node is F. Next time I will say the current node is G. Next time I will say the current node is D. Right? So, so that's what I'm doing here. So if ch is equal to dot, then all of my children, right? So this is the children, and I'll just check syntax. So this is my, if this is my children, then the children will be hash map, right? So right, so children will be, any node children will be on this structure, right? Key value pair. So that's what I'm doing here. So this is my key and this is my value, and the value is a node, right? So all these values d, f, g, d, all these node values will be a children node, will be a current node. So first of all check if what present, this children will be a current node, and if if this returns true, right? If this returns true, then I return true immediately. But if it does not return true, then I need to look for, suppose now we are looking at D, and now we look at E, F. So we are not searching for this, right? So if this is dot, suppose if this is F, then okay, this ends with F, so it will return true immediately, right? So this will return true immediately. Now we don't need to look at another children F, so this would just return true immediately here, and this would just return true immediately. And yeah, this would return true immediately, and yeah, and this function would return true at last, because this would return true and return true. But yeah, but if it doesn't return true, then we will look at other functions also. So if any function doesn't return true, then what happens? I mean, if none of the function returns true, then what happens? So suppose we are looking at D, then D, E, F. So this is also, suppose if this is G, then this will return false. So we are looking this way, this way, this way. Let me think. And then what happens? That is the question. So if I'm doing I plus 1, then if this is I plus 1, then children would come on. I was just checking if I plus 1 is the start index, and it would start from there. This function will return true only after it reaches till the end. So yeah, in the normal scenario, we'd say current A, C. It would just return false immediately. It would not come out of this loop, right? But in this scenario, if there is a dot here, then dot, this will return false, this will return false, this will return false, and this will also return false. At that point of time, I will still be equal to 0, 1, 2, 3. So it will continue, right? So I will still be equal to I will still be equal to 3 in this case 0, 1, 2, 3, and it will come out of this loop. I think that what I can do is I should just return false here, right? Because if there is a dot value here and all the directions, it returned false. So in that case, I should return false immediately. Yeah, I need return false here for this scenario. Then if any of the doesn't fail, then this will return false. Yeah, am I missing anything else? So what if there is dot, another dot? So if there is dot here, then also that is fine, right? If there is a double dot also, then it is the same thing, I think. Yeah. Since this is a recursion, it is a kind of weird recursion function. Should I create a base case or something? What is the base case of this recursion function? Base case of this recursion function is base case of this recursion function is, oh, what did I do? For, and this is a, okay, this is a function, and this function will look at the current node and the start index, and this start index is of the word, and check if there is a word. If the start index is this one and if the current node is this, then it will just check if the um, if there is a all the values present in that word from that start index and from that current node, right? So because it starts with start index I and then ch, and it would see if current node the children ch, otherwise it will update current node. Actually I don't even need else here. Or yeah, let's skip as, because I don't even need else here, because if it has dot, then it will just go here and it will return false from here only. So yeah, if we encounter dot at any point, then the path will be very very different. It will not, it will just it will have to return true from this path only, from here. But if there is no dot, then we will just go through this. I hope that this will work. Prototype search, read properties of undefined. Should I put it here? Current node the children, oh, check syntax. Current node the children is not here. I need to check syntax. So it is like, I think since this is a current node children is a hash map, I cannot iterate it like this. So I should do object dot increase. Yeah, so this is not iterable, but object dot increase will change it to iterable array kind of structure. Object dot increase. Oh wow, this got accepted. 16 test cases passed. So this is true and this is false. Okay, add word. This sort is returning false. So we are adding 80 and 80 and 80 and an is already here. Oh, 80 is all 80 and 80 and an add and add, and so this, there are 4 add words. These are the 4 add words: at, and an and add, and the source word is a. It will return false, but it is returning true. A should not return true. Why did a return true? While I'm searching, this start root will be the current node and 0 will be the start node. And if I'm starting with 0, then word dot length will be just 0 only, and start node will be a in the beginning. And since it is not equal to dot dot, It will see if calling know the children as ch or not, and oh, it will return false. It if does not have return, then it should return, um, at last it should return, if current node has dot each word in word or not, word in or not, right? Because it is just saying that, oh, a is present here and it is returning true, but we should also check if a is the end word or not. Now this will pass, that case will pass, but do I need to change anything here? This will return true. What if there is dot? What if there is just one dot? Then what will happen? If there is a dot, then then it would just pass any children, right? So any one of the children, it would be, and I will be equal to I plus 1, so it would just return. Oh yeah, I think this is fine. Oh, what did I do? Where was the mistake? Dot. Oh my god, it worked. That's great. Thank you for watching, everyone. Bye.